This is our video explaining textbook section 6.3 where we multiply a vector by a scalar. When we want to multiply a vector by a scalar, we end up getting a new vector. So when we multiply vector v by a scalar k, notice just from that first little sentence that v is a vector and k is a scalar, and we know that just by looking at it because v has a little arrow on top, but k does not. We end up with a new vector which we will call kv. Notice that the little arrow doesn't go on top of the k, it just still only goes on top of the v. If that's the case, our new vector has the same direction as the original as long as k is positive, and the opposite direction if k is negative. And we can also write the magnitude of the new vector kv is equal to the magnitude of vector v times the magnitude of k. So in our case, the magnitude of k is actually going to be the absolute value of k. There are some properties that are true when we're multiplying a vector by a scalar. So these properties are going to look very familiar to you. The first is the distributive property. So we can multiply over a bracket if the scalar is outside of the bracket. Similarly, we can put two scalars together. So it doesn't really matter how you group things up. And finally, we can distribute over addition if there's only one vector and you have two scalars. So you end up with scalar k times vector a and scalar m times vector a. So these rules don't mean a lot until we actually look at a few examples so you can see what it's going to be like in practice. If we want to draw some new vectors, I'm just going to draw them right on top here. If this is vector v, we don't have a coordinate system or anything. We just have vector v existing there. It has a particular length and it has a particular direction. If we want to start by drawing 2v, we're going to make sure that our new vector goes in the same direction. So it doesn't actually matter where I start it. Wherever I start it, I want it to go in the same direction, but it has to be twice as long. So this went across 2 sort of diagonal squares. So I'm going to draw my new vector, and it's going to go across 4. 1, 2, 3, 4 squares. This is 2 times vector v. The actual location of where I decided to draw it does not matter. So I could move it over here, and it is still equal to 2v. Or I could move it right on top, and it is still equal to 2v. So the actual physical location doesn't matter, just that it's going in the same direction and has twice the magnitude. Let's do the next one. Negative 3v. So the negative means we're going to go in the opposite direction, and the magnitude is going to be 3 times as long. So I'm going to go, that would be negative v. 2 more would be negative 2v. 2 more would be negative 3v. Next, we're going to do 1/2 of v. It's not the scalar is not negative, so it's just going to be half the magnitude. And finally, the last example there, we're going to do negative 1/4 v. So it's going to be a quarter of the length of v, and it's going to go in the opposite direction. Something like that. Negative 1/4 vector v.